EVN. EVN or Easy Virtual Network. In this video, I'm going to show you what is the EVN and also how we can configure the EVN, and finally how we can verify the EVN. First, we should understand the concept, the function of the EVN. After that, we can configure the EVN. EVN is an advanced feature that is the next step of the VRF-Lite. You know the VRF-Lite. In this video, I'm going to review the VRF-Lite feature, and after that we can understand what is the advantage of the EVN over the VRF-Lite. Let me to first start with the reviewing the VRF-Lite, and after that I'm going to show you the concept of the EVN. In this scenario, first I'm going to configure to show you VRF-Lite feature. Okay, you know that with VRF or virtual routing and forwarding, we can create for example, virtual network over one physical network. Okay, virtual routing and forwarding light feature. Okay, let me to show you. For example, assume that we have one router here. This is the first router, router 1. Okay, and also we have the second router, router 2. This is the router 2, and we need to create two virtual network, two isolated virtual network with this only one physical network, R1 and then R2. Okay, let me to show you the VRF-Lite feature. Don't forget, now I'm going to review the VRF-Lite. You need to understand, to know about the VRF-Lite, and after that you can learn the concept of the EVN. Okay, assume that we have one link between router R1 and router R2, and we need to for example create two virtual networks, two isolated virtual networks with this only one physical network. Assume that we have for example two interfaces in R1 and also two interfaces in R2, and finally we have one link between R1 and R2. You know that we can create VRFs. VRFs means virtual routers in a router. As for example, let me to show you how we can create VRF. This is a VRF. VRF is a virtual router, is a small router inside of the for example physical router. It's such as the VLAN in a switch. VLAN is a virtual switch or virtual LAN. VRF is a virtual router. This is a VRF, and also this can be another VRF, and you can attach the physical interface to one VRF here in R1. Now in R1 we have two virtual router or virtual router and routing and forwarding instance VRF. For example, A, the name of the VRF is A, and the name of this VRF is B. For example, VRF A and VRF B. And also, you know that we can for example use two physical interface or two sub interface on a link for connecting VRFs in two routers. Assume that here in the for example router 2 also we have two VRF, the two VRF, VRF A and VRF B, and this VRF now is connected to the physical interface. Okay, in R2 also, such as the R1, we need to create two virtual network. Okay, this is the VRF A, for example, and then VRF B. Okay, don't forget the name of the VRFs can be different and between two routers. Only the uniqueness inside of a router is important. And now we need to connect the VRF A's traffic to the VRF A's of or R2, VRF A of R1 to VRF A of R2. One of the methods that we can configure is using the sub interface. Let me to show you here. Assume that this is the for example GE00, and then this is the GE00. Okay, we can configure this GE00 to two sub interface. The first sub interface is a GE01 okay? And the second subinterface is GE002, okay? Also, we can configure the same in subinterfaces in the R2, and then we can attach one of these VRFs, for example, VRF-A to this subinterface, and also we can attach the second VRF-B to the second subinterface, and finally we can attach the VRF-A in router 2 to the GE0001 and VRF-B to GE002. Okay, now we have two virtual networks, and also we have one physical network. Let me to show you. For example, if a traffic receives here, this is the PC1, okay, and this is the PC2. Assume that PC1 can send the traffic to the PC2, okay, with routing. R1 can send this traffic over the, for example, this subinterface with the tag .1q tag of, for example, 2. Assume that in configuration of GE001, I configured the GE001 with the .1q tag of 2 and the GE002 with .1q of 3, or maybe let me to configure here, it's easier to understand in the GE00. Look at here, interface GE00. We need only no shutdown command. And also for the interface GE001, I'm using these commands, VRF forwarding, and then VRF forwarding, for example, A. After that, encapsulation .1q, okay, .1q2, and for example, IP address is 10.121.255.255.255.0. Also, in router R1, I'm configuring the GE002 here with the VRF forwarding B, for example, encapsulation.1q3. IP address can be same with the IP address of the GE001 because this is the GE002 reside in the other VRF than the GE001. This is the configuration of the GE001 and GE002. And finally, if a traffic received from the VRF-A, this traffic can send to the router 2 with the tag of 2, this .1q tag. And finally, when this traffic reaches to the, for example, R2, because we have the same configuration in the R2 with the IP address of 10.122, for example, R2 can understand that the .1q tag of 2 is for the GE001, and it can de-encapsulate the packet and after detag the packet, and after that it can send the original packet to the, for example, VRF-A, and finally these packets can reach to the, for example, PC2. And also, if a PC such as the PC3 sends a traffic to the, for example, PC4, here we have the distinct path, and here we have the different virtual network. Because of that, the traffic of PC3, let me to show you with different color here, the traffic of PC3 now can pass over the, for example, G002 with the tag of 3, this tag, that 1Q tag, and when the packet receives to the R2, the packet can de-encapsulate, and after that the packet as a original packet can receive to the PC4. This is the method we used in the VRF-Lite. VRF-Lite is a good feature, and we can use it for creating virtual networks over a physical network. You can configure many virtual networks over a physical networks and use the advantage of the separated virtual networks. But here we have a problem. We have one administration overhead, and that is when you are creating, for example, 100 VRFs, you need to configure 100 sub-interface, and this is not easy, and the EVN is the solution for the scalability problem of the VRF-Lite. Let me to show you how we can use the EVN to easier configuration of the, for example, virtual networks over one physical network. EVN, okay, EVN is a abbreviation of the easy, okay, virtual network, easy virtual network, and the name of the abbreviation of the EVN can show us that EVN is an easy method. We can use the EVN for configuring easier the virtual networks over the, for example, one physical network, easy virtual network. Okay, how EVN can help us? Let me to show you. When you are configuring EVN, some part of the configuration is similar to the configuration of the VRF-Lite, but also some other part of the configuration is easier. Okay, let me to show you. You know that when you are configuring VRF-Lite, first you should configure the VRFs in the routers, and after that assign the VRFs to the interfaces. Let me to show you, let me to review for you. For example, you can configure the VRF-Lite or VRFs with two commands. The first command, the traditional command, is the IP VRF name. Okay, this is the first command. And also you can configure with the newer method, VRF definition. Let me to configure with the newer method, VRF definition in router 1, or for example R1. Okay, and also you need to enable the address family of IPv4 unicast in the for example for this VRF, and also we need to configure the VRF R2, VRF definition R2, VRF definition A for the first VRF, and VRF definition B for the second VRF, address family IPv4 unicast. Okay, after that we should assign the VRFs to the interfaces. Let me to name this interface Fast Ethernet 00 and also this interface Fast Ethernet 01, for example. Here, now we should configure these commands: interface Fast Ethernet 00, VRF forwarding, okay, VRF forwarding, for example, A, and then we can assign the IP address, for example, 10.101.255.255.255.0 and no shutdown. This is the configuration of Fast Ethernet 00, and also we have Fast Ethernet 01 with this configuration, VRF forwarding B, okay, then IP address, okay, 10.101, for example, 255.255.255.0 and no shutdown. Okay, this is the configuration of the VRFs, and after that we should configure the for example interface G00 with this configuration. Okay, in EVN, when you are configuring the VRFs, you should configure a new feature. We call it VNet tag. VNet tag means virtual network tag. Let me to show you. Look at here. For example, when we are configuring the VRF definition A, here we should configure a new feature. We call it VNet tag. VNet tag. This is a random number between 2 to 4094. For example, I'm using the VRF tag as 2. Okay, that's it. And then address family IPv4 unicast. This is the configuration of the VRF-A. Also for VRF-B, I'm going to configure VNet tag, for example, 3. Okay, and another commands, for example, assigning the VRFs to the interfaces are same. But here, between the router R1 and R2, we don't need to configure the, for example, sub-interfaces. We are using a feature, we call it VNet trunk, or for example, a link such as the trunk link in the switching. Let me to show you here. Interface GE00 now has an IP address, no shutdown. IP address, for example, 10.121.255.255.255.0, and finally I'm using this command VNet trunk. VNet trunk means this links, this is such as the trunk link, and it's so easy to configure. Only one command, vnet trunk. Also in the for example router 2, I'm using this command. Now the other features are same with the VRF-Lite. How? When for example PC1 sends the traffic to VRFA, VRFA can forward this traffic to GE00. You don't need to configure these sub interfaces, okay? But because you configure for the VRFA VNet tag 2, okay, because of that, when the traffic should go to the should send from the for example VNet trunk, this is the VNet trunk link, okay, such as the switching trunk link, the traffic should tag with the tag of 2, the tag of the VRF. Look at here, PC1's traffic reached to the fast Ethernet 00, and R1 knows that this traffic is for VRFA, and the VRFA's tag is 2. Because of that, because R1 should send this traffic to other interfaces of the VRFA, or and also to the on the trunk link. On the trunk link, such as the switching, it should tag the traffic with the tag of 2, and now the tag of 2 now is attached to the traffic, and after that it can reach to the R2. In R2 again, the traffic receives in R2, and because we have the same configuration in the R2 VRF definition A, for example, okay, VNet tag 2, R2 can understand that this traffic is received for the VRFA. Because of that, the traffic can de-encapsulate and or detag, untagged, and after that traffic can send to the PC2. This is so simpler than the VRF-Lite. You don't need to add a new configuration in the interface GE00 when you are, for example, configuring new VRFs, because this is a trunk link. You don't need to configure other for example sub interfaces for new VRFs. Let me to show you how you can configure the EVN, Easy Virtual Network, and after that we can talk about the more features of the VRF. But before that, as you can see, the EVN is a method to configure VRF-Lite simpler, okay? It's combination of the VRF-Lite and the features such as the trunk links in the switching, okay? It's so interesting. Let me to show you how we can configure EVN and how it's easier, it's simpler than configuring the, for example, VRF-Lite. Okay, this is our scenario. In this scenario, we have two routers, router R1, router R2, and also we need to configure 2 VRF in router R1 and also 2 VRF in router R2. And after that, we can configure the, for example, Ethernet 02 between the router R1 and R2 as a trunk, as a VNet trunk. Let me to show you the configuration. First, we should configure the R1. enconft host name is R1. So easy. First, we should find that if we have any configuration, show VRF. Okay, look at here. Show IP, VRF, for example, we don't have any VRF. Let me to configure the VRF first with the newer method, VRF definition. The name of the VRF is A. Here we need a new feature. We call it VNet tag. VNet tag can a unique number, can be a unique number between 2 and 4094. For example, I'm using the VNet tag as 2 for the VRFA, and also we need to enable the, for example, address family IPv4 unicast, address family IPv4 unicast. Okay, that's it. And then we need to configure the next VRF definition, for example, B, and then VNet tag is 3, okay, and then after that we should configure address family IPv4 unicast. That's it. Let me to show you the configuration until now. Show IP VRF show us that we have 2 VRF. The name of first is VRFA and the second is VRFB. If you want to see the detail of the VRF, such as the VNet tag, you can use the show IP VRF detail. Look at here. Show IP VRF detail can show us the detail of the VRF. VRFA now has a VNet tag. The VNet tag of the VRFA is 2. And also the VNet tag of VRFB is 3. Okay. Okay, the next step is to configuring the, for example, ETH00 and ETH01 for using this VRFs. First, I'm using the ETH00. Interface ETH00 now is a member of the VRF-A, VRF forwarding A, and after that, the IP address of this interface is 10.1.255.255.255.0 and no shutdown. After that, we should configure interface Ethernet 01. The VRF forwarding is B for this interface, and the IP address is same as the IP address of the ETH00. IP address 10.1.1.255.255.255.0 and no shutdown. Okay, let me check again the VRFs show IP VRF. Look at here, show IP VRF now has two interface, for example, for the VRF-A we have interface ETH00, and for VRF-B we have interface ETH01. Don't forget, RD is a feature for MPLS VPN VRFs, and we are not using the RD in the VRF-Lite or EVN. Okay, after that, here we can check two routing tables. Show IP route for the VRF-A, we have one connected networks, and show IP route for VRF-B, we have one connected networks for the VRF-B. Okay, that's it. This configuration is same configuration as the VRF-Lite, but only adding one new command. Let me to show you VNet tag. Look at here, VRF definition A. This command is new. VNet tag is 2 for the VRF-A, and VNet tag is 3 for the VRF-B. And also, let me to show you one important things. IPVRFC, this is the traditional command for the configuring the VRF. IPVRFC, look at here, VNet, we don't have the VNet tag command. Because of that, if you want to use the EVN, you should configure the VRFs with the newer method, with the VRF definition command. Okay, that's it. Let me to configure interface ETH02. You know that in the VRF-Lite feature, we should configure this Ethernet 02 with many, for example, a sub interface. Here, we don't need to configure sub interface, and this is the benefits of configuring the easy virtual network. It's easy. Okay, interface ETH02 now is a VNet trunk. Okay, is a VNet trunk link. It's so interesting, VNet trunk. And after that, we should enable it, no shutdown. IP address of this interface is 10.1.2.1, for example, 255.255.255.0. And now we can check again, show IP VRF, show IP VRF. As you can see, let me to delete the VRFC, no IP VRFC, okay? And then do show IP VRF. Look at here, do show IP VRF can show us that we have we have the VRF-A with the interface of ETH00 and also ETH02.2. This is so interesting. I didn't configure Ethernet 02.2 and only I configured ETH02. And as you can see, it automatically creates the ETH02.2 because this is the, for example, this is the sub interface for using in VRF-A. Let me to show you. Show running config. Okay, in show running config, you can see that I configured the Ethernet 02 as a VNet trunk. Okay. This is the show running config. But we have one interesting commands. Show, for example, derived config. Derived config means the derived config of my configuration. Okay. Show derived config can show us that here we have this configuration. Okay. This is the derived config of my configuration. I configured interface Ethernet 02 with the VNet trunk. The IP address is 10.1.2.1.255.255.255.0. And these two sub interfaces now is created, is derived, okay, from my configuration. Interface ETH02.2 description sub interface for VNet A, because I configured for the VRF-A the VNet tag as 2, it creates the interface ETH02.2, okay, and encapsulation.funq2 VRF forwarding A, the same IP address is used. This is the drive configuration, okay? I didn't configure these commands. I configured interface ETH02 with VNet trunk, but the iOS automatically generates this configuration. It's so interesting, okay? Show drive config. Okay, finally we should check, we should review all of the topics, but for now it's good. Let me to go to the R2. Here in R2 again we should do the similar configuration. Router config hostname is R2, VRF definition A, then VNet tag, it should be same with the router 1, VNet tag is 2 for example, and then address family IPv4 unicast now is enabled for this VRF. Again, we should configure the next VRF definition, for example B, address family, or for example first we should configure VNet trunk, okay, VNet tag as 3, and then address family IPv4 unicast is enabled for this interface, for this VRF. Okay, now we have two VRF. Let me to show you, show IP VRF, VRF A, VRF B, and also we assign the VNet tag to this two VRF. Interface R2 conft interface ETH00 has this IP address, first VRF forwarding A, then IP address 10.202.255.255.255.0 and no shutdown. Again, interface ETH01 VRF forwarding B, IP address 10.202.255.255.255.0 and then no shutdown. Finally, in the interface ETH02, it's easy to configure only one VNet trunk command, and after that the IP address 10.122.255.255.255.0 and finally no shutdown. That's it. Now we have this scenario, VRF-A, VRF-B with this configuration. Also, you don't forget, you need some method of routing to route the packets from the VRF-A in R1 to the VRF-A in R2. Assume that we can use the, for example, a static routing in the R1. I'm using this command, the same command as the VRF-Lite. IP route VRF-A means this static route is for VRF-A. For the network of the PC2, 10.200.255.255.255.0, use the 10.122, the next hop. This is the IP address of the router 2. And also, for example, you can configure the same command for VRF-B, because we use the same networks in the VRF-A and also VRF-B here. IP route VRF-B 10.200, okay, and the next hop is same. Also, we need to configure these static routes in the router 2 for 10.100 with the next hop of 10.121, 10.121. That's it. Let me to configure these commands. In the router R1, show IP route VRF-A can show us that we have two connected networks. One connected network is the ETH00 and one other connected network is 10.120. And now we need one static route for VRF-A. IP route VRF-A for 10.200.255.255.255.0. Please use 10.122. That's it. And also for VRF-B, we should use the IP route VRF-B for 10.200.255.255.255.0. use the 10.122. That's it. Also in router 2, we should configure these commands. IP route in VRF-A, okay, for 10.100.255.255.255.0. use the 10.121. And also for the VRF-B, IP route VRF-B, use the same command. Now we can check the routing table of R1 for VRF-A. Show IP route VRF-A, okay? Here we have now one static routes, and also in VRF-B, we have one other static routes. And finally in router 2, show IP route VRF-A, okay, and VRF-B. Two static routes now is available in VRF-A and also VRF-B, one static route in each VRF. Okay, now we can check the connectivity. For example, I can give the VPC1 one IP address, IP 10.1.0.10, with mask of 24, gateway is 10101. That's it. And for the, for example, VPC2, this VPC, I'm using the same IP address. IP is 10.1.0.10 with the mask of 24, gateway is 10.1.0.1. Okay. And for VPC3 and VPC4, I'm using the IP address of 10.2.0.10 with the mask of 24 and the gateway address of 10.2.0.2. And for VPC4, I'm using 10.2.0.11. Okay. 24 10.2.0.2 is our gateway. We should use the IP keyword. So easy. First, let me check the connectivity between VPC1 and VPC3, and also we can capture the link between router R1 and R2. Let me enable the capture ETH02 capture. Please capture the ETH02. Okay, this is the capture. This is the Wireshark. And after that, I can send the traffic from first VPC1 to the VPC3, and after that VPC2 to the VPC4. Let me to check only filtering the ICMP packets. From the VPC1, this is the VPC1, please ping here from here, please ping the 10.2.0.10. Okay, this is the IP address of VPC3. We have connectivity, and here we can check the tags. Here, look at here, the traffic received from the 10.1.0.10 to 10.2.0.10. As you can see, ICMP, IP, and now we have .1q tag, and the tag ID is 2. And this means that when the traffic received from VPC1 over the ETH00, one of the interfaces of the VRF forwarding A with the VNet tag of 2, the traffic should sense over the trunk link with the tag of 2. Okay, this is a trunk link. This is a layer 3 trunk link, and the tag 2 is should be untagged in router 2, and finally it can reach to the VPC3. And after that, for example, I send ICMP echo request from VPC2 to destination of VPC4. Let me to show you here from the VPC2. I'm using the command ping 10.2.0.11, the IP address of the VPC4. Yes, we have connectivity. As you can see here, we have the traffic from the 10.1.0.10 to 10.2.0.11. As you can see, the tag is 3. This is the easy virtual network. It's so similar to the configuration of the for example, VRF-Lite, but it's easier. Why? Because in VRF-Lite we should configure many sub-interfaces between router R1 and router R2, but here we don't need to configure sub-interfaces. We need only to configure one command, VNet trunk, and after that all of the sub-interfaces are created automatically with EVN. Let me to show you some useful, for example, show running config. Show running config can show us the configuration of the VRF definitions, or for example VRF itself, and after that it can show us the configuration of the VRF over the interfaces, ETH00, interface ETH01, interface ETH02. But if you want to see the derived config, you can use show derived config. Show derived config is so interesting. Let me to show you. For example, for the ETH02, the derived config of my config of the VNet trunk config is that creating the two sub-interface ETH02.2 and ETH02.3. Okay, if you configure another new VRF, here we will have one new sub-interface, and this sub-interface will create automatically. So interesting. Also, if you want to see only the features of a VRF, for example, the config of a VRF, show running config VRF-A, you can use show running config VRF-A. As you can see here, we have only the configuration related to the VRF-A, VRF definition, VRF forwarding, VNet trunk, and also a static route. Or for example, show IP route VRF-B. Only the configuration related to the VRF-B now is can be seen. Okay. Also, if you want to see the VNet, for example, show running config about the VNet 2. Okay. For example, about the VNet, you can use the show IP route VNet. Look at here. VRF definition A, VNet tag 2, and also interface ETH00. This configuration for VRF-A. And after that, the VRF-B configuration can be seen. These commands are used for filtering the running config. These commands can be used for filtering the running config to see the focused information that we need. Okay, very good. How is Easy Virtual Network can help us to reduce the, for example, administration overhead? It can configure automatically automatically sub-interface in the links between the routers. It's the function of the Easy Virtual Network. But don't forget, with Easy Virtual Networks, we will find a new advantage, and I will talk about them in the future videos. Let me, before finishing this video, reviewing the configuration of the, for example, Easy Virtual Network, EVN configuration. Some part of the configuration, as you saw, is same as the configuration of the VRF-Lite. For example, configuring the VRFs, assigning the VRF to interfaces, but here I'm going to review these topics. Router config. You can configure the VRF with the VRF definition. Don't forget, you can't configure the VRF with the traditional command IP VRF, okay? You should only configure the VRF definition command. Your VRF definition, then VRF name. After that, we will go to the router config VRF. Here, we should configure the VNet tag, a number between 2 and 4094. After that, we should enable address family that we want. For example, address family IPv4 unicast, address family AFI means address family identifier, and then SAFI means subsequent address family identifier. For example, IPv4 unicast, okay? And after that, you know that we should assign the VRF to the interfaces router config. Interface, okay? Interface name, and then router config if, okay? After that, we should use the VRF forwarding, then VRF name. And then, for example, for the VNet trunk link, the link between the routers, only we need to configure router config if VNet trunk. That's it. It's so easy. Okay, don't forget, you can configure, you can monitor the VRFs with the show IP VRF or show IP VRF interfaces, or show IP VRF detail, for example, detail. And also, if you want, you can check the show running config with the VRF name or with the VNet keyword. And finally, you can verify the configuration with the show derived config. Very good. Now you can configure Easy Virtual Network, and it's a advanced method of configuring the virtual networks over physical network.